Hey, welcome along to today's presentation about perceived quality in the 3DEXPERIENCE platform. I'm pretty happy to talk to you on the DCS conference today. Thanks a lot for inviting me. And welcome to my humble home office. My name is Dresemann. I'm working for CATIA Design in the product experience team. In there, I'm working as a portfolio technical specialist for 10 years now. Before we start, I'd like to thank Opel for providing us the model to showcase the capabilities of the 3DEXPERIENCE platform. And a special thanks goes to Jens Scheak, who provided me a lot of information around the model and the use cases. Thanks a lot. So, what is this presentation about? Firstly, I would like to talk about the company Dassault, for those who do not know this yet in detail. Then I'd like to continue a little bit at CATIA and why we in CATIA need visualization. Then, why is it important in terms of perceived quality and what is perceived quality? How we do perceived quality in the 3DEXPERIENCE platform. And to summarize what you have seen and give you an outlook what will come next. We are a purpose-driven company and we think of progress and innovation. We have around 20,000 people worldwide across 130 countries. We have 69 R&D labs and I'm pretty proud of that. 290,000 customers in 11 countries are distributed around the world. And within that, we are having the largest PLM and 3DEXPERIENCE market share. DCS is one of our 12,600 partners, which increases our knowledge. And 3DCS is a very long partner of Dassault Systems since 1998. The market share has been consistent since we started. It is owned by the group Dassault, which is the family Dassault, and the company's management. Our presence is around the world, divided in 3 headquarters. One is in Paris, one is in Boston, and the other one is in Shanghai. So we distributed our people around the world very equally. We have 40% in Europe, Middle East, and Russia, 30% in Asia, and 30% in America. We have a proven track record to make our things happen. So we started in the very early 80s with 3D to represent surfaces of things. That was the launch of CATIA and to create engineering parts and assemblies in 3D. We did this with the help of Dassault Aviation. Within that, the next step was clearly to put everything together. Not only 3D parts, assemblies, entire systems, complex systems, inside and outside. We did this with the famous 777 from Boeing, which was the first digital 3D mockup. Then we introduced 3D PLM, product lifecycle management. So we brought and represent now time into that. We did this together with Toyota. The 4th stage then is what we are at the moment, the 3DEXPERIENCE, to represent perception and emotion. So today, value lies in the usage rather in the product itself. That's what we call the experience economy. We've proved that with the Singapore city. We are entering the 5th stage in the very near future. We hope to do that with the help of metadata. Imagine of being able to test and cure a human body like we do with planes and cars. This is what we call the virtual twin experience of human. Moving from the representation of things to life. And here comes our profound belief that we think the virtual world can extend and improves the real world. And achieving a more sustainable future is only possible by leveraging the virtual world. In life, we do not have rehearsals. So we are struck to do that in the virtual world, and we can do that. We can simulate and see the impact of that before we are building the product itself. And in CATIA, we are thinking the same. We want to move on and do exactly that. Extend the virtual world where we can. How we can contribute to the Dassault success. We are serving 3 communities. The one is the designers, the engineers, and the system architects. Today I'd like to focus, of course, on the designers, but with a strong collaboration to the engineers, because perceived quality has a strong collaboration needed. But firstly, to understand, before we can move into that, we need to understand the trends and innovation trends of our customers, because those are the trends and the demands for visualization needs, new visualization needs. For example, products inspired by the nature, new generation of UI and UX, collaboration and social innovation, or new approaches of perceived quality. The topic of today, what we want to talk about. So those are the drivers for visualization. That means visualization is key. But why is it so key and why is it so important? Visualization, nor VR, is not about just making things prettier. VR and realistic visualization is also a communication tool. So let's have a look at this problem here, what you can see. You have a bunch of people who's talking to each other, and the first one is starting and the last one is totally thinking about something else. So that could be due to language barriers, due to different knowledge. A lot of things could happen why we have misunderstanding. So communication is key and we need visualization for that. But not only that, it is an enabler for collaboration. Because if we have one common understanding on that level, because we can see a visualizing thing, everybody understands what it is about, and you can collaborate and work together more efficiently. To do that, there is key to understand where we come from and why we need to have the 3DEXPERIENCE platform. Because in the past, you had a shaping tool, you had a visualization tool. Between that, there was conversion needed. So that process was fine so far, but there was always something missing. If you need a change, a modification change, the shaping had to start again and the conversion had to start again as well. So the whole process was still interrupted. So wouldn't it be better if we could integrate everything in one tool? Of course it would. So we integrated the workflow, everything in one tool. Shaping along the visualization context, shaping along VR if needed, or using just VR as to get the first person view in a realistic one-to-one scale. So what is perceived quality? Perceived quality needs a lot of disciplines, and I think therefore we can really prove that perceived quality is a great example for collaboration and integrated workflow. You can see just here on that slide that the surface department is involved, the illumination department is involved, of course the global visualization, the global quality, visual quality is involved, as color and trim and gap and flush. All this can be covered by the 3DEXPERIENCE platform. For example, the surfaces, to define the best design related to its functions. And the color and trim, look at that. The definition of the surface to the treatment to choose the best material distribution on the shapes. You have direct connection between both two things. And then of course, gaps and flush, another direct connection to both, because that defines the product quality relating to its manufacturing process. And everything is related. So collaboration is key. Not only that, those things are a great example of design, of the design departments. There are other departments involved. I already mentioned that the engineers are involved, and we have a strong collaboration need for them. As well, the quality department and the product planning department are two departments which really have a need of the perceived quality topic, because in the end, quality defines the brand, and the product planning is about to do everything as cheap as possible with a certain quality aspect behind that. Let's have a look when we do perceived quality. We like to do perceived quality in all R&D phases, from start to end. So let's have a look at the timeline. And if we start with the design, going through the engineering phases to a full technical release, building our first prototype, and then starting to evaluate, can we do this for the mass production, and doing our first physical prototype tests, our first perceived quality tests, we are lagging information here in the end. So if we really start that late, we have time issues in the end. Let's do that everything digitally from the very start point and all the time. Within that, we can collect a lot of information to put those into the first physical prototype and sufficient these reviews later on. So let's have a look at the overall process flow and a dedicated or a closer look between designers and engineers and which challenge comes with it. So the designers are telling us or defining the overall design language, the colors, the trim, and of course they do also define the gap distances. So they define what is acceptable from the design perspective. The engineers then analyzes and can simulate those things. They can evaluate, can we do it? Can we not? Can we do it like you want in the design department? And then output could be a prediction based on the Monte Carlo simulation. This can be done by the 3DCS integration tool. We'll see that just right away. But before we do that, both departments have a clear need of collaboration in the 3D experience. They want to see what happens if we do that, what happens if we do this. So why not putting both together and putting them in front of the 3D experience to do a live demonstration or live review? Those decisions can be made easier by collaboratively working together and steadily improve the workflow of the product and the product itself, of course. To do that, I'd like to give you an information about our roles we have, which really would help you here. So the first one is the visual experience designer, which is for the overall visual appearance to make realistic visualization. On the other side, we have the PPX, our product presenter designer, which is perfect for design reviews or engineering reviews. Combining that with the tool from DCS, the 3DCS variation analyst, we have the best package to do those reviews. And this is what I want to show you now. Let's have a look.
Hey, welcome back in the 3DEXPERIENCE platform. I switch off the camera to really focus on the software and not on my face. Let's directly start. As I told you before, we are starting on the designer side. And for that, I'm in the CATIA Product Perception Experience application. So this is our application where we can do design reviews. And to do that, we are jumping into the play mode just by clicking here the play button on the compass. And what we got is a really nice UI. We can adjust that here. This UI enables us to look at different variants, in this case in the color and trim variants. So we have different kind of base colors here available. We can switch them through. Looking pretty nice, I would say. And then if we gonna like some of those, we can name them as a favorite, or we can accept them or also reject them. So really use that tool as a review tool. We can go into different view modes or viewpoint modes, let's say that, and then switching through the colors again. That's pretty nice, I would say. Here we have a nice car paint with nice flakes, I would say. Looks pretty nice. Let's go back into the overview mode. And you can see directly that those views are interpolated. So quite nice to really get a nice flow into the presentation, I would say. So let's have a look at different roof variations. I think also looks pretty nice. We can use also, very cool in here, so-called triggers, and we can click, in this case from the A-pillar, on the A-pillar here for the accessories, in this case the mirror, and in the front here we can use the triggers here. We can also cycle through by using some triggers for the hood here and the fender. This looks pretty nice. Let's have a look. Let's have a look for this. I think there could be a nice solution. Oh yeah, this looks pretty nice. Definitely. We can have a look in the ray tracing mode. So we have the stellar render engine capabilities inside the presentation mode and also in the offering mode. And we can have a look how the car will look like with correct reflections and correct shadowings. That looks pretty nice, I would say. Okay. Using that, we can mark all active variants at the moment within a favorite icon. So for later presentations, we know that this is one of our favorite combinations. What we can also do is we can capture this variant as a so-called stage variant. So we will have them later on after our review available. And it will also capture the viewpoint with it. So very nice feature, very cool to select one. So let's see if we find another good example to save. Oh, that looks also pretty nice, I have to say. But now, if we think about gaps and flashes, this is our main topic today. Perceived quality and gaps and flashes, of course. Which colors do contribute the best to investigate in analyzing gaps and flashes? So I would say there's definitely a big benefit if we use bright colors. So let's have a look at a closer point at these two parts here. Those will be the point of interest today, the triangle patch and the mirror patch. As you can see, we can still use our free navigation. If we want to capture a viewpoint which is looking nice to us and we want to reuse that camera perspective, we can also use just the capture viewpoint variant, and it will capture later on. It will capture for us the viewpoint, so we can reuse them process later on. So that's pretty nice. I think we can capture this as a stage variant as well. Let's compare this with a dark color. This one will be always black. Maybe we can have a white A-pillar instead of that. Maybe a white roof. And also, let's use white mirrors here. Okay, I think we can capture this as well. And as I told you, we have now done kind of a perceived quality design review. And this is always the first thing what will happen. The designers will tell the engineers or will go into the detailed analysis of a car and define the acceptable design language, colors, and trims. What is missing is the part of gap distances. So for that, you will see just in a minute that we can have a look at these as well here in the combination view of those two things. So what we got now after the presentation ended, we got our viewpoint, our fourth viewpoint, just updated here. And we got our presentation of our stage variants. So what we can do now is we can click on this first stage. It will automatically apply the capture variant, so with a red roof and the grayish color. Or we can go into the second stage, which is with the new viewpoint we've selected, and can jump back and forth between those two colors. So let's start with the white color. We will restore the windows down, and now we have the side-by-side view. So here on the left, we are able to see the 3DCS application, which is opened as soon as I click on it. And here we have still our PPX session available. And what I will do, because we are liking this situation here, this viewpoint, we are linking both views together at the same on the same point. So if you move something here, it will automatically move here. So just you can see that. I think that's pretty cool. So let's do it a little bit on that side so that we can see it here a little bit better. Reduce the size of my presentation window, and then jump into the DCS application. Inside the DCS application, we will use the spec study viewer, which enable us to show some of the spec studies we have predefined as designers. So what does it mean? That means we can view different situations. The designers say, okay, this is acceptable in terms of minimum gap between the triangle patch and the mirror patch. And this will be the maximum deviation. So because we want to focus now on the different colors, let's reduce the size here a little bit on the left side. And now we can use different colors to have a look how they will appear up here, and we can really compare those two things just by applying a new color and see how this looks like. And from the designer standpoint of view, we are happy with these kind of variations so far. In the black color, so let's have a look again on the white color maybe. Look at the minimum status or minimum values, the lower specification and the upper specification. So from the design point of view, the designers set up a bunch of inputs for the engineers. So the next step will be then that the engineers are going to analyze and simulate what is possible and see if this solution, what the designers came up with, is feasible or not. So we are closing this one. We are extending the DCS application. And the first thing what we will do then is we are going into the nominal build and then separate the parts. So this should first of all explain you what the engineer is doing now. So the engineer has to think about how to assemble those two parts to the car. In this case, the first idea the designers came up with was to use each part separately and assemble these separately to its fender, so the triangle patch to its fender, and the mirror patch, just let me click on it, to the side body part here behind that. You will see that here the bolts and maybe some holes are missing due to the limitations of the geometry we have. So what we can do is now we can click on Animate in the 3DCS application and click on the full process to show you how this will be built. So this is also helping to get a better understanding of both of the parts, how they will be assembled. So this was scenario 1. This is the initial scenario the designers came up with. So the next thing will be then to run an analysis. Okay. So by just looking at the numbers, this is what an engineer is normally doing, is that he can see, okay, we have a total estimation out of specification of almost 26% at the first measurement, which is this measurement here. We have slight numbers at different measurements, for example here on measurement 5, which is the measurement between the triangle patch and the fender. And then we also have one between the mirror patch and the door, and one between the hood and the triangle patch. So those are the 4 biggest numbers. Let's have a look at that specific number, because I think that could be interesting to see what that does mean for us as an engineer, as a result. So let's have a look how the minimum, or how how it looks if we are looking at that end and then at the other end on the maximum, and see if the designers would accept such things like that. So what we get now here is we are getting a huge gap here around that, and also here we are getting some issues. So we have a kind of an A gap here. You're running into some complications also here, which is kind of fine because we still not see it, kind of a little bit, but due to the same colors, we are kind of fine. But let's have a look at the maximum situation. I think that is even a bit worse. We are running into some issues here on the top, which is okay, which looks kind of interesting, but that is kind of a big value. So what we need to do now is we are just seeing these things without the correct shadowing and the correct reflections, right? So what we should do now is we should jump to live rendering, CATIA live rendering. Just getting rid of the windows here, not a big issue. And within live rendering, of course, we have all the capabilities. So live rendering, just for you as an explanation, a very short explanation, is our tool for visualization. Here we can do all the nice things, setting up the material, setting up camera position, stuff like that. So because the camera position is really interesting for us, this is the first thing we should do. We should save the camera position to our current view, to our scene, so that we can definitely come back to the camera position and compare it later on in the process. Now let's switch on Stella. And now we can see the differences also in reflections and shadowing. So let's see a little bit from another angle how that looks like. And still we can see here the part below, which is kind of not really nice, and I think in terms of quality not what we want to really show in the end. So if we compare that with the minimum value, I think the minimum value is not that big of an issue, because we have still here still nice shadowings, which is kind of hiding all the parts behind it, and still here not the biggest issue. Definitely the bigger issue is the maximum value on the right side, because we can now see things we couldn't see before. So if we take a look at a specific sample in the middle, and you really see how that should look like normally. There is definitely something to do on the engineering side, because most probably the designers will not accept the situation. So what will be the next steps? We are going back to the 3DCS variation analyst. The engineers thought about, okay, how we can change that we having here a nice gap, because we have an issue here. It seems to be that the issue here and here is not that big, because we have nice shadows and can really hide things if they are out of specification. So their idea was to think about, and for that we'll separate the parts again, to think about a different way how to mount both things to the how to mount both parts to the car. And they came up with with two more scenarios. So that was the first scenario I just showed you. And the second scenario is the following. As you can see, before we do that, 3DCS has nice model variants which you can automatically apply and now investigate new ways how to assign those, how to build those parts together and then get different values out of that. So what we will do, a little bit difficult maybe to see here. Let me show if I can show you that properly. Yeah, I think that's a good view. So what we have done, or what the engineers came up with an idea, is to take those two parts, put them together relatively always in the same perspective, so that we, in terms of the gaps and flash, we are speaking of a zero gap. So we have always the same distance between the triangle patch and the mirror patch. And then, so those two parts attached with a third part. We do not have them at the moment due to the geometry. But just imagine those two parts are connected to a carrier element. And this carrier element is then applied to the fender in this case. Showing you the third variant. I can just click on the moves here, which is then later on is the same setup. We have again a third element, the carrier element, but then this time we are connecting it to the side body part. So we have again the perfect match between those two things. Having said that, we are running two more analyzers to save a bit of time. I've already prepared that. As I've told you, we have now for the first gap a zero gap. That means we have now we have set them so relatively together that they have no deviation. So they're always perfectly fitted together. So that means we have reduced the number, the first number, from 25% or almost 26%. We have completely get rid of that that problem, but we've introduced another one. So to see here in the scenario 2, we've introduced an issue on measurement 5. You can have a look at that. You see that is measurement 5, and also here, which is measurement 17. So I think we can definitely say, okay, we have to take a look at that. But just before we do that, let's have a look at scenario 3. And just by looking at the numbers on scenario 3, we can see that we have also some issues on measurement 5 and 17, but the numbers, just the numbers, are not that high. So just in comparing by the numbers, we should think that scenario 3 is the best one. So now let's compare scenario 2 with scenario 3. And what I mean by that is, let's compare this not by the numbers, let's compare it visually. And now I think here comes the real big benefit. We can compare not only numbers, as engineers can understand, because engineers do understand those numbers, but what is now the purpose is that you can use those numbers and show that to designers, and they can decide, okay, is that still an acceptable situation we'd like to have, or do we need to take a look at another solution, Let's take this one, which is 38% out of specifications, and have a look at the minimum situation. We are speaking about measurement 5. Measurement 5 is just to bring you back that into your mind, between the fender and the triangle patch. Of course, still to remember that as well, those two parts are connected kind of together and moving accordingly. So we're now getting different issues. We get rid of those gap here, which is kind of important because we have seen something in here. And now we have to take a look if this is an issue. Let's have a look at the minimum situation. Okay, that is something where we get a flush situation. Let's have a look. Let's have a look. Okay, we introduced a huge gap in here. Let's introduce the maximum situation. Oh, okay, we have introduced a huge gap in here. And I think here that is kind of fine. Still here, that is pretty small. Okay, let's switch back to this situation. I think, okay, we also introduced something on that measurement as well. So actually not that good, I have to say. Let's have a look at the measurement 17, which is between the fender and the hood and the triangle patch, which is even worse, I would say, here in this situation. Okay, this is definitely not good. This is definitely not good. And we are definitely out of specification. So this is something our design department will not allow to have such things. And this is the cool thing. We can now see, okay, this is not only 38% out of specification, we can really see, or 34, we can really see that these values do have an issue if we're running out of these specifications. So now let's have a look at the third scenario, again on that measurement here. Okay, this is also pretty bad, actually. But if we compare that, and if we say, okay, we have just 12%, which is out of specification, and we are definitely more fine here on that gap. And let's have a look at the maximum situation in here, which is much better, I would say. Really need to take into account and see, okay, and compare which is the better solution in the end for our car in our manufacturing processes. So if we take a look at the measurement 17, I think that's definitely absolutely okay. This is a situation which we can live with, and designers can live with it as well, because it's pretty fine, I think, just from looking at these numbers. The only thing which is kind of probable, could be an issue, is, I think, the maximum situation here, because we have a really tight gap here and a huge value here. So again, we have defined the numbers. We have seen some issues, and now we can dive deeper into this issue and this discussion here, because what we are doing now is we are switching on ray tracing again. And for that, we will switch to CATIA Live Rendering again, bringing back our windows and clicking on Stella. Okay, from that angle, we can now see that we have here maybe an issue, and we can look through the fender into the engine room. Okay, that could be an issue, and this is definitely something worth looking at more in detail. So the maximum situation is, from that point of view, definitely not that big of an issue, because we have a nice shadowing. Both parts are still getting a nice gap for us, and we can not look through those things. The same goes for this gap. So that looks pretty nice to us, I think. Just have a different look at from that angle. I think here the flush value, or the flush situation, is not that bad. Looking at that situation is also okay. Here we get a little issue on that side. Despite the fact that the rendering capabilities is pretty clean and pretty fast already in this case, there's still some graining and some noise here available around the part applied, and it's difficult to really see the differences just by clicking on those numbers and then getting the differences just at the same point. So what we will do is we are using a capability which called background rendering. This capability is helping us to understand a certain camera point of view, and we have already set that up before, right? Is to use the camera view. We can apply that to the current view using the camera management tool. Getting in here, camera 4, looking at that from that angle of to the camera, and we can define some iterations so that we can later on in the offline review process provide those images upfront to some colleagues to discuss that. Additionally, to the need to our live review where we get the direct feedback. For that, we are starting to use, for example, the minimum value of scenario 2. We will name that accordingly, and we can submit the background rendering. This will do then a rendering in the background, and we can have a look just in the presentation after that how this looks like. I will do this now for the measurement 5, 17, and for those two scenarios to compare which one is then the best. This was my presentation in the 3DEXPERIENCE, how we can do perceived quality with the help of DCS, with the help of a design tool called Product Perception Experience, and with the help of the Visual Experience Designer, which allows us to simulate and show the realistic rendering capabilities. I think we've shown that this is already pretty nice, and I could prove you that we can do perceived quality in the 3DEXPERIENCE. Thanks very much, and we will see us just right again in the presentation.
Okay, let's summarize. What we have seen was great. 3DEXPERIENCE in action, we have seen live rendering, we have seen how fast we can get to some solutions where we find the benefit of 3DCS, of the full 3DCS integration. So whether it's from the designer's perspective, doing shapes, doing materials, lighting, ray tracing, whatever it is, or the engineers who are doing the assemblies, new production assemblies, processes, everything is related and everything is in the 3DEXPERIENCE. We can fully integrate all of these disciplines and everybody can work together collaboratively as best as possible. And at any time, you can jump into your VR experience. Unfortunately, due to the home office, I don't have a headset with me here. But I think Ben got a video, an older video of mine, where you can see that we proved 3CS variationalists can work with VR together.
Okay, here are some batch renderings from the live session. This is scenario 2, and we're looking at measurement 5, which was the one you can see below between two arrows. On the left side, we have the minimum value, and on the right side, the maximum value. Let's compare that with the scenario 2 and the measurement 17. And you can see that there is a difference, and we can now better and more easily see and directly compare between those two things. What is the difference? What is the what is the values we should look at, and do we have some issues? Below you can see again where is measurement 17. So this is the idea of how you can use offline renderings additionally to your live review session. A short disclaimer here at the end. I want to mention all those scenarios were discussed with Opel together. I don't know which solution has made it in the end. The nominal situation is the situation as the car was built. So we've tried to replicate them in our own way. That does not mean they are right and they are completely right in terms which scenarios or which results they got in the end. So just an idea how you can do perceived quality, in this case on this example with different scenarios.
If you're now interested into more, then please go to our website, 3ds.com, or follow us on our social media channels on LinkedIn, YouTube, Twitter, Facebook, or Instagram. Stay tuned for more perceived quality videos in the near future on our dedicated YouTube CATIA design channel. I hope you liked my presentation. Thanks a lot for your attention. I'm happy to answer all of your questions if you have one. I think we are opening the Q&A session right away. Thanks a lot. Have a nice day for those who are getting out of the presentation now, and see you soon. Bye bye.